All right, so today we'll be going over the properties of logs. So the first one here, I'll just label this number 1. This will be the product property. Okay, and here we have log base b of m times n. So this right here is actually the argument of the log. This is m times n. And what you can do with the m times n is break it up into log base b of m plus log base b of n. All right, so the bases on all the logs matched are all log base b, and the argument m times n gets broken up into m plus n. So how can you remember this formula? Well, it's similar to the one with the exponents, okay? If you had, let's say you had x to the power of a times x to the power of b. What does that equal in terms of x? Well, you would just take these exponents, a and b, and add them. Okay, that would just be a plus b. So it's the same thing with the log property. All right, so when the argument of the log is a product, you can break them up and add it. So let's look at some examples. All right, it says use property 1 to rewrite the logarithms. Here we have log base 4 of 7 times x. Okay, 7x is the same as 7 times x. So we're going to break this up. So let's start with log base 4. And I'll leave the parentheses here, plus log base 4. Okay, this is a product, 7 times x. And we have log base 4 on both of them. And instead of 7 times x, the 7 goes here, and the x goes right there. All right, so that's it. Please pause and see if you can do the same thing on ln of 15t. So here, ln, that's the natural log, that's log base e, but that's irrelevant. Okay, this right here, 15t, is your argument. Okay, that's 15 times t. So here we had log base 4, here we just have ln. So I'm going to write ln and leave some parentheses, plus ln and leave some parentheses. All right, in the parentheses here we have 15 times t. So I'm going to write 15 here, and I'm going to write t here. Done. All right, log base 6 of 19t squared. All right, so that's the same as 19 times t squared. So we have a log base 6, parentheses, plus log base 6, parentheses. Okay, 19 times t squared, so that's going to be 19 right here, and t squared right there. All right, see if you can do the last one. All right, we have the log of 100 times y to the 4th. So we're going to use log, and parentheses, plus log, parentheses. All right, this is 100 times y to the 4th. So here we have 100, and here we have y to the 4th. Really, that would be it, but they have it as solving this problem. So this part of it, at least. So I'll show you real quick. Log of 100 is the same as log of 10 squared. Okay, and the base on this log, when there's no base, that's automatically a 10. Plus log of y to the 4th. Okay, and here, since the bases match, the 10 matches the 10, those cancel, and you're left with the 2. Plus log of y to the 4th. All right, so that's it for that last problem. Now, really, the truth of the matter is, you can get a number for this or this or this. You can get numbers for all of these, but it's going to be an ugly decimal. Okay, but right here, it was just a 2, so I think that's why they actually solved this log here and made it a 2. All right, 2 more examples, and in these examples, we're going in the opposite direction. Here, they're already added, and what we're going to do is we keep the log base 9, which we have on both problems, log base 9. All right, and now the argument here is a 3, and the argument here is a 27. So this is going to be 3 times 27 for the new argument. Okay, so in the parentheses, it's going to be 3 times 27. So here we unpacked it. All right, we went from the product to the sum, and now we're going the other way around, from the sum to the product. All right, so we're just doing it the other way around, and we keep the log base 9. All right, 3 times 27 is going to be 81. So that's it. Okay, here we have ln and ln. They both match, so I'm going to keep the ln part of it. And then the argument is going to be x and radical y. So we're just going to multiply x times radical y in the parentheses. Okay, there is nothing we can do with that. So it's just ln of x radical y. There's nothing to combine right there. All right, example 2. We are looking at the quotient property. Log base b of m divided by n equals log base b of m minus log base b of n. So when the argument here is a fraction, when it's divided, it's going to be the numerator minus the denominator. Okay, and how can you remember this one? Well, remember, if you have x to the power of a divided by x to the power of b, and you want to write this in terms of x, you just subtract the exponents going down. A minus b is the new exponent. So same thing here. It's going to be m minus n as the new, when you break this up, it's going to be m minus n as the new arguments. All right, so now we're going to use property 2 to rewrite these logarithms. All right, we have the log of x divided by 4, so let's rewrite the log and leave some parentheses, minus, rewriting the log, leave some parentheses. Why did I use minus? Because the argument of this log here is a fraction. It's divided, x divided by 4. So the first term is the numerator, that's the x, and the second term is the denominator, that's the 4. All right, and that's basically it. All right, please pause and try this example right here, the same way we did number 1. So we have a quotient here for the argument. This right here, 5 divided by x, is the argument on ln. All right, since we have a quotient, we're going to be subtracting. So we keep the ln, and I am going to use a minus because we have a quotient for the argument. The first argument is the one from the numerator, that's a 5. And the second argument is the one from the denominator, that's an x. All right, so it's just ln of 5 minus ln of x. Made it a little messy here, but you get the idea. All right, in this one, we're going to work backwards. So make sure the base numbers match. Okay, we have log of 15 and log of 15 on both of them. So I am going to start with log of 15. All right, and the argument, remember the number that's written first is in the numerator, and the number that's written second, or the second argument after the subtraction, is in the denominator. All right, try this one right here, please. So here we have an ln and an ln. Okay, let's keep the ln. The first argument is a 16, so that goes in the numerator. And the second argument is a t, and that goes in the denominator. There's nothing more we can do with this. It's just ln of 16 over t. All right, one more. We have log base 4, and we have a quotient or a fraction, so it's going to be minus. All right, so let's keep log base 4 minus log base 4. All right, the numerator is going to be the first term, and the denominator is going to be the second term. Now, in the book, since this is not a decimal, they actually solved the first one. If you'll notice here, 4 is the same as 4 to the first power. Okay, when the log base matches this base here, they cancel, and it's just a 1. This right here, you could find a number, but it's going to be a long decimal, so we just leave it as is, log base 4 of 3. All right, so that's basically it. And just like last time, you know, some of these, like the log of 4, you can get a number, but it's going to be a decimal. ln of 5 is a decimal. Log base 15 of 3/2, those are all decimals, so that's why we just left it. But here it was clean. It just canceled out into a 1. All right, last one. We'll call this property number 3. This is the power property. And it's actually pretty simple. Log base b, and the argument here is m to the power of n. This whole thing right here is the argument, and what you do is you take the exponent here and you just move it out front, and it is multiplied by the log. So if you move the n right here times this log and the n cancel, it's going to be n times log base b of m. All right, so that's what we have here, n times log base b of m. All right, so you can just take the exponent. You can just take the exponent and move it out front. And that is only when this right here, the argument, has the exponent on it, m to the power of n. And where does this come from, or how would we remember it? Well, if you have, let's say a number a, oh no, I always used x. So let's see, if you have x to the power of a over b, that is the same as the root of x And this number in the numerator is going to be the exponent a. And this number here in the denominator is going to be the root b. So these are similar if this helps you remember it. All right, last set of examples, we are going to be using property 3. So let's see. Here we have log base 4 of 3 to the x. Pretty simple. We said before, you just take the exponent. First off, this is the argument right here, 3 to the power of x. That's the argument. On the log, you just take that x and you move it out front. So it's going to be x times log base 4 of 3. And that's it. Okay, and on this one here, we're actually working backwards. Okay, this is 1/3 times ln of t. So in this case, we took the exponent and moved it out front. Now we're going to take the term out front and move it into the exponent. All right, so it's going to be the ln of t. And on that t is going to be an exponent of 1/3. So it's basically ln of t to the 1/3. All right, here we have log base 6 of radical 2x. We need to rewrite this with a fractional exponent. All right, so that's going to be log base 6, and instead of radical 2x, we're going to make it 2x to the power of 1/2. Okay, when 1/2 is the exponent, that's the same as the square root. And this square root is applied to this whole thing, so the 1/2 is going to be moved out front. So that's going to be 1/2 times log base 6 of 2x. All right, so here, once again, this needs to be converted into a fractional exponent. So we have ln, and we have the t, and the exponent on the t, well, let's see. The exponent on the t is a 3. That goes in the numerator. All right, let me rewrite that. The exponent on the t is a 3. That goes in the numerator. And the root of 4, that goes in the denominator. So it's ln of t to the 3/4. All right, I'll use parentheses right here. And now we're in business. All right, what we're going to do is take the exponent and move it to the front. So we're going to start with 3/4. And that's going to be times ln of t. That's it. All right, see if you can do these two, please. All right, here we have the exponent of 2. We can just move that out front. It's going to be 2 times the log of x. All right, let's see. Right here, we're going to work backwards. This -3 is times log of 8. 8 is the argument. Okay, so the -3 is just going to come in front of the, it's just going to go in front of the 8. That's going to be the exponent on the 8. All right, so the negative 3 becomes the exponent, and we're left with the log of 8. And the exponent on that 8 is a negative 3. So it's the log of 8 to the negative 3.